Okay, so one of the biggest learning opportunities that I've seen for students is in the form of actual interventions with real life patients. This one is a intervention that I came into. I inherited this patient in a situation where we had a lot of airway resistance that was self-induced by some of the settings that we had. So looking at this, and these changes happen 2 minutes apart. You can see right here 6:19 and 6:21. So right here, these settings, we had an I time of 0.6 and we had a peak pressure of 31. Now, in order to understand airway resistance, we remember that the airway resistance is a difference between PIP and plateau. That would be your larger airways and the resistance that they have in them. And at that time, my plateau pressure was around 21 to 22, which would create an airway resistance of approximately 9 or 10. So, in order to fix this, you want to make your I time longer so it softens flow impact. So through our recording here, you see that we have a flow right here at its peak flow around 80. So if you have small airways and you're sending a lot of flow into that, it creates a lot of airway resistance. Now 2 minutes later, we extend the I time out, and right here you can see that it goes from 80 to a peak flow of 53. So then you slow down the flow, you get laminar flow rather than turbulent flow through the airways, and the large airways and smaller airways, your peak pressure drops from 31 to 24. They have a better relationship with each other. So then more of that pressure makes it to the alveoli. The alveoli inflate and you get better CO2 elimination and better oxygen distribution. This is a common response to some of the education I see and some of the motives of a therapist to eliminate CO2. So education often says you should increase your or decrease your I time, make it faster to give longer time to exhale for CO2 to eliminate. That's not true. And I don't think it's a great way to teach this concept, because what happens when you reduce your I times, you make more flow faster, you make turbulent flow. That pressure does not make the alveoli where the magic happens. Those alveoli collapse and you get worse CO2 elimination out of the blood. You need to inflate the alveoli and get better CO2 elimination. This patient had a CO2 of 83. Whenever we reduced the airway resistance and started having a relationship and inflating our alveoli, our minute ventilation obviously dropped and our CO2 went down to 62. So the minute ventilation went from 15 down to 12 and then down to 9. And basically that means you're doing more with less. Your alveoli are working more with less. So that is the ventilation you should strive for. Airway resistance is often induced by large amounts of flow. It can be also the tube size, secretions occluding your airway. If you rule those things out, you need to look at your flow and how fast it comes in. But this was all a self-induced matter.